Okay, 2.6 related rates. So why are we doing this? Well, let's solve some real life problems and see why we're doing derivatives. Okay, so derivatives are the instantaneous rate of change. And so when things change in the real world, it is changing instantly. Things are happening. Water is draining from a pool. A bucket is filling up with water. Those are not at a constant rate because water pressure changes. The drain might get clogged, things like that. So an important use of the chain rule is to find the rates of change of two or more related variables that are changing with respect to time. An example of this is when a water is drained out of a
funnel?
Yes, but a conal tank, and volume and radius, because as the volume decreases, the radius of the cone is also decreasing, correct? Because it's here and getting shorter and shorter and shorter. Okay, so volume, if you don't know volume, you need to know volume. This is of a cone, is pi over 3 r squared h. You might need that today.
That's volume of a cone.
Volume of a cone. R is radius, h is height. So as that water drains, my radius is changing. So I need to figure out the rate of change for the radius. And so we will have different problems that you will have to know today. You'll need to know the area of a circle. It's an area of a circle.
Half of base of height?
No, that's the area of a triangle.
Oh.
Pi r squared.
Yes.
Okay. So if you don't know the formula that you need for your homework, you probably should look it up.
Do we need triangle?
Well, triangles are flat objects, so no. Well, we do need...
You know what I meant. Whatever we were just talking about. Circle. No.
You will need a sphere, but we will do that in a problem that we have going on. There are some helpful... In the section in the book, there are some helpful formulas that you need. I will tell you, like a sphere, I think you should know if it's anything off the wall like this, I would have it on the test for you. Okay, so suppose x and y are both differentiable functions of t and are related by the equation y equals x squared plus 3. Find dy dt when x is 1, given that dx dt is 2 when x is 1. So how you are going to write these problems is you're going to write them on your paper and you're going to write equation. Okay, so what is the equation?
X squared plus 3. Y equals x squared plus 3.
And you're going to write given. Now, I do not care if you write find or given first. I like my find at the end. Okay? I'm given what?
X equals 1 and d of x over dt.
Dx dt. You don't have to say over. Equals 2 when x is 1. And what do they want me to find?
dy dt when x equals 1.
So dy dt. So if they want me to find dy dt, that means I have to take the derivative of the equation. And if I take the derivative of the left, I have to take it of the right. So you take d dt of y and d dt of x squared plus 3. So d dt of y would just be dy dt, wouldn't it? Because it'd be 1 in front. The derivative of y would be 1.
This is why we did this on Friday.
Yep. Okay. And then I would get, well, the derivative of x squared would be 2x, but we are in terms of what? T?
Yep.
So I have to put, or dx dt. We're not going to put prime on these because we're doing two different, we got multiple variables going on. And I feel I think it's more confusing than it needs to be.
It's not just y prime.
Right. And then the derivative of 3 is 0. Okay, so now that we have this, we need to plug information in. We were given this, yes?
Yeah.
We were given this information.
So
So I need dy dt when x is 1. So dy dt equals, we're plugging this in. So 2 times x, what's x? 1 times dx dt. What is dx dt? Say it. 2. So dy dt is 4. So you're going to have to figure out the equation. Sometimes it's obvious. Sometimes it's like slapping you in the face. Other times you have to read the word clues. Good? Okay, so now a pebble is dropped into a calm pool, causing ripples in the form of concentric circles. Concentric circles look like that, circles inside of circles. Is that what it looks like if you drop?
sure. You bounce a rock.
If you bounce a rock, you get a bunch of them. Okay, as shown in figure 2.34. The radius r of the outer ripple is increasing at a constant rate of 1 foot per second. Don't be writing anything. I didn't tell you to write anything.
I'm writing an equation given in
Well, don't write that. Unless you're just writing the words. Don't write what they have
just
down.
writing the words.
Oh, okay. So if you want to, when you get to the problem, if you want to write equation given and find right away, you can. That way you know to find that stuff. Okay, the radius r of the outer ripple is increasing at a constant rate of 1 foot per second when the radius is 4 feet. At what rate is the total area of the disturbed water changing? So to me, I think it's easier to figure out what I want to find first. At what rate is the total area changing? Okay, so that would be dA dt. What's A stand for? Area. And T stands for? Time. Okay. Well, let's see. When R is what?
Radius.
But R is what? 4. Okay, so that's what we're supposed to be finding. So we need an equation and we need a given. Well, what equation am I going to be? What?
4 pi squared.
A
Your
equals
equation.
pi r.
A equals 4 pi squared.
Not 4.
But radius equals 4.
No. We don't do any of that. That's after we're done. We can't plug anything in before we start. So how did we know we were using area?
It says
It says area, right? Okay, what else do we know? What's our given?
radius is 4 feet.
We got that already.
dr dt is 1.
Because it says what?
1 foot per second.
dr/dt equals 1. And I like to put my units. They don't put their units. That bugs me. If I don't put my units, I tend to forget my units, which is not a good thing, right? Okay, so I have to find what?
The area.
No, not the area.
Of the area.
What's dA/dt mean?
Rate.
What does d/dt mean?
Derivative.
Derivative. So I have to find the derivative of the equation that I wrote down. So I am not going to write it out like I did the last one. I'm just going to go dA/dt. I'm just going to do it. Here, if you want me to do this. Is that better?
No.
Okay. Anyway. And pi is a number. It's a constant, right? It's a coefficient?
Yep.
Okay. So I get 2 pi r dr/dt. So I found the derivative. So what do I know now? Plug in. So dA dt of 2 pi times r, 4 times dr dt, 1. So I'm pretty sure 8 pi feet squared per second. How do I know it's squared?
Because the equation's weird.
Yeah, but we're talking about area, right? Isn't area always squared?
Yeah.
So once you find the equation, the given, and the find, it tells you what to do, correct?
Yeah.
So you just have to step through that. I got 2 more examples for us.
This is all weird.
Mm-hmm. Am I good?
Yeah.
Oh, this is guidelines. They're in your textbook if you want to write them down in detail. I don't know if we want to, I can go back to them when we're done if you want, but it's identify the given quantities and quantities and determine, sketch and label a graph, write the equation, use the chain rule if you need to, and substitute back in. So we wrote the equation, the given, the find. We found the derivative of the equation, yes, and then we plugged in. We haven't drawn a picture yet. Some of them you may want to draw a picture. You may want to see it in your brain. Okay, here are some things. The velocity, vocabulary statement. The velocity of a car after traveling 1 hour is 50 miles per hour. X is distance traveled, dx dt is 50 miles per hour when t is 1. See how the statement relates to the information? Water is being pumped into a swimming pool at the rate of 10 cubic meters per hour. So volume. How do I know it's volume?
It's a pool.
Well, it's a pool, but it also says 10 cubic.
Right.
Is cubic volume?
Yep.
Yes. So you got to look for your word. So V equals volume of the water of the pool. dV dt is 10 cubic meters per hour. A gear is revolving at a rate of 25 revolutions per minute. 1 revolution is 2 pi radians. So theta is the angle of revolution. d theta dt is 25 times 2 pi radians per minute. Do those statements make sense from left to right? Okay, so you'll just have to read them. Sometimes you reread them. I would always encourage you to write it down, what you think, and go back and reread. Okay? So before we start reading, what do you guys want to write? Okay. And some people write f of x, but I don't like to write f of x because sometimes it's not enough of x, right? Okay, air is being pumped into a spherical balloon at a rate of 4.5 cubic feet per minute. Find the rate of change of the radius when the radius is 1 foot. Not foot, 2 feet. Okay, what's my equation? Volume of a what? Balloon, which is a sphere. Okay, so you don't know that, but you can look it up, and it is 4/3 pi r cubed. Okay, what was given to me?
Wouldn't that be R equals 2?
Well, it says find rate of change when r is 2, so I would put that with the find, but you could put it with the given, but there's something else given.
4.5 cubic feet per minute.
So what is that?
1.
No, but no, like, okay, so 4.5 is 8 halves, yeah, or 9 halves.
That's the speed.
It's the change of what?
Rate.
The rate of change of what?
The air being blown up.
Foot per minute.
We don't
Feet
know.
per minute.
We don't know.
Okay, what is 4.5 cubic feet per minute? The what?
Rate of the
The volume. So dV dt equals 9 halves cubic feet per minute.
Do I have to put it in fraction form?
Well, when we're going to do math, it will be easier because we have 4/3 that we're going to have to deal with. And it should be, it will be easier. Okay, so now what do I need to find? Find the change. So what's the change? What do I do to do change? dr dt when r is what? 2. That when r is 2, you could put it with the given, but that's really not a given. It wants to know what. Now, guys, why is it dr dt and not just r? Because I want the rate of change. Okay, and derivative is the instantaneous rate of change, correct?
Yep.
Okay, so what do I need to do? Find the derivative. So the only equation I have is v. Now before we've had like r, right? But there's really not an equation for radius, is there? No. So it would be dv dt equals what?
Wouldn't it be 4 pi r squared?
4 pi r squared.
Cubed.
No. Then what's after? We're doing with respect to time, and we just differentiated r, so what goes after it?
Minutes?
For D.
dr dt.
Oh, yeah.
Because we're doing implicit differentiation, yes? Okay, but what are we trying to find?
Do we have to put those letters behind it?
Yes, that's implicit differentiation. Yes. Okay, what are we trying to find though?
We're trying to find
dr dt.
So we need to solve this for dr dt, yes?
Yep.
So if this is multiplication, then I have to divide by it, right?
Yep.
So dr dt would be equal to 1 over 4 pi r squared dv dt. So now what?
I don't know.
What do we do now?
Plug something in.
things in.
Now we just plug things in.
The 2.
What
So dr dt equals 1 over 4 pi times what?
2.
2 squared
Squared.
times what?
9 halves.
9 halves. So dr dt 9. Well, 2 squared is 4. 4 times 4 is
16.
times 2 is
32.
so 32 pi. And we're radius, so that would just be feet per minute. I put second on my paper, but it's not second, it's minute, isn't it?
Yep. Wait, why did we go 1 over 4 pi r squared?
Because we wanted to solve for dr dt, and this wasn't solved for dr dt. So it's multiplication, so
Oh.
you multiply by the reciprocal. So sometimes your equation's set up like you need it, and sometimes it is not.
Done? Can I give it
Nope, one more.
One more.
One more.
One more.
Okay, and it's going to say, like in the picture, okay, an airplane is flying on a flight path that will take it directly over a radar tracking station. If S is decreasing at a rate of 400 miles per hour when S is 10, what is the speed of the plane? Okay, so our equation. I have given, and I have. Okay, so if S is decreasing at negative 400 miles per hour when S is 10, what is the speed of the plane? So which variable is speed?
X.
X. So what are we finding?
X. Speed.
S.
How about dx dt?
Yeah, that's what I said.
So what do we know?
When S is 10.
Okay, we know when S is 10.
No, find dx dt when S equals 10.
Okay, so now it's going to be on the given.
S is
Oh
decreasing
my
at a
God.
rate of
Because it says
400.
S is decreasing at a rate of 400 miles per hour when S is 10. It doesn't say find the speed when S is 10. But Cadence, I'm going to tell you, either place you put it, it will be okay. But that's why it goes.
It's not okay in this way.
Okay, anyway. So what do I have then?
S decreases at a rate of.
So what is that?
Decreasing rate.
So what is it?
I don't know.
ds dt. Why is it ds dt?
Decreasing speed.
Because that's its rate of change, yes? And if it's decreasing, it's not positive, it is
Negative.
negative miles per hour. That H is horrible. Okay, so what's my equation?
I don't know.
It's a shape, guys.
Triangle.
So what's my equation?
1/2 base times height.
That's the area.
Well, Dad, nothing about the area. What, guys, what kind of triangle is that?
90 triangle or
It's-
369. I don't know.
It's a right triangle. So what's the equation to solve for the length, the side lengths of a right triangle?
I can't think.
I don't know.
I just think I'm so kind. It's in my head. It's in my head.
That's a question
It's
for
hiding
Google.
it. It's playing hide and seek right now.
Well, it's not a question that I'm answering, so you guys better figure out how.
Riley, look it up quick. What am I asking?
Um,
What?
How do you find the side of a triangle?
Like, how do you find the sides of a triangle?
Or right
On a
triangle.
right triangle.
How do you find the sides of a right triangle? Oh, base and height are the two sides. It says, in a right triangle, the base and the height are the two sides that form the right triangle.
Base times height.
No.
What
I
am I
got
trying
it.
to find?
It's in my head.
What am I trying to find?
Equation for, what am I doing? For right triangle. It only comes up with area missing there. Oh, the Pythagoras theorem.
Pythagoras.
Shut up.
So the Pythagorean theorem,
It says Pythagoras somewhere.
because Pythagoras was his name, but it is the
don't care
Pythagorean
about
theorem. So that is the hypotenuse squared plus equals the two sides
Yes.
squared. Okay, so what is the hypotenuse?
S.
S squared equals,
6
Square root.
squared. S squared.
It's 6 times
X
X.
squared.
6
X.
squared. 6
so what is 6 squared?
36.
36 plus
X squared.
x squared. Thank you very much.
This is weird.
6 times X. I'll punch you right now.
Okay, so what do I need to do?
Derivative, plug in.
Okay, so I need to take the derivative.
Yeah.
Yes.
2s.
So
equals
I'm
0 plus
so
2x.
2s ds dt.
Oh no.
You guys have to put that because we're taking the derivative with respect to what?
I don't know.
Not at
Respect to ds dt.
no respect to t, time. Okay, what's the derivative of 36?
Zero.
0.
ds dt.
So 2x dx dt. Okay, so it wants dx. So that means I have to divide by 2x, correct?
Yes.
So dx dt equals, well, if I divide by 2x, isn't it just s over x? ds dt. So now we would plug things in, yes?
10.
So what's s?
10.
10?
S tense.
What's x?
That's a good question. 400.
No?
We have find x.
We got to find x, don't we? What's ds dt? Negative 400?
Yeah.
We need to find x.
Yeah.
Well, if I have s is 10 and I have 36, can I find x squared? Can I find x? So x would equal the square root of 100 minus 36, which I'm pretty sure is 64, which is, square root of 64 is 8. So x is
X is 8.
8. So if it gave me s, it's just like when they give me x and I need y, I've got to plug it in to find y, correct? Okay, well, 8 goes into 400, negative 50. So dx dt is negative 500 miles per hour. And the reason why it's negative is because I'm getting closer. Because we don't put miles per hour negative usually. This is a physics thing when you do your vectors. Yep, you're going towards something, so you're decreasing, away from something, you're increasing. Okay, so that is what you're doing today and tomorrow.